Hey everybody, how are we doing? Let me cut the volume in the background. You might be hearing the music. You might be hearing me. There we go, and I think I have everything set up properly here. How's everyone doing? I think can we do task 5 as well, please? You bet, Macy. Hannah asked first about visualization number 4, then we will do task 5. People are already working very hard. I'm going to extend the 320 assignment till next week. The graders will get a week off, so the graders should be super excited. Hannah, what questions do you have about visualization number 4? Let's hop over here to the main screen. If I hit the main screen button. Here we are with visualization number 4. It's data. It's very important we have the visualization for assignment open, which should be somewhere. Let me go get the visualization assignment for assignment. So visualization assignment 4 coming up this week, this Friday. Here is visualization assignment 4. And we're going to start with a little visualization assignment 4. I'm a little confused on how to set up the pivot chart. Let's go ahead and take a look at that. So do you have the pivot chart kind of opened and ready to go? To get your pivot chart, download the data from following. Make sure you have Excel on your computer. You will go right here. You will download the data. Now, it's very important we know that the first pivot chart is set for you. You need to make this one. I don't think I've made this one during office hours any. You bet, Macy. And we'll definitely do that next here. Thank you so much for everyone showing up if you're watching this right now. And so we got a new command too. Let me show this real quick. Is it? Does that work? Is it working? Mubot should respond to that. Mubot, you're supposed to tell us how many times Puppet Target said yeah. Is the counter not going? It is going. Oh, it's yeah. It's now this. That's what I put in as the command. I changed the command on that. So it's Mubot should respond to that now. Mubot, tell us about Puppet Chart. So with this, we have right here. Thank you, Mubot. So we have here pivot chart 1, pivot chart 2. Let's work a little bit on pivot chart 2 and do a possible pivot chart 2. The one that we did earlier today, it was meh. So let's go ahead right here. And it's all right if your pivot chart is not the most interesting thing in the world. It matters that you can explain it. So once again, if you're watching this for 201, we're not looking that you change the world with some sort of analysis right here. We're looking that you can make a pivot chart, can properly put context to that pivot chart, and then explain that context. So let's see this in action. You're going to open up the data, which we saw there just a moment ago. You're going to hit Control or Command A. That's going to select all the data on the screen. That button's going to pop up, which I don't remember popping up. You're going to then go to Insert, and then go to Pivot Chart. And or Pivot Table, excuse me. It's already got everything selected, and then you're going to hit OK. So once you hit OK right here, you will then be presented with the options. And I'm going to vanish off the screen and go to the zoom in option we have here so you can see what I'm doing. So I just have a zoom in on this area so it's a little clearer to see. And for pivot chart 2, we need a what type of variable for the variable we're going to analyze here. What kind of variable do we need? And actually, I might do this one today. We need to pick a quantitative y variable. So I'm going to take this quantitative y variable and put it here. And now a very important thing we need to know immediately is that we don't want to analyze the sum. So how do we change this down here? What are we going to change about the value field? We're going to change its what. What are we going to change about the value field? We're going to change the what for the value field. The value field is, we're going to change its something. Starts with an S. It has a what. There's a very important thing with making a pivot chart is we don't want to sometimes display the sum every time. Sometimes we want to change what we're displaying. We change this via the setting right here, the value field setting. So the value field setting is going to change the way that this is displayed. And we can see right here, I'll have to zoom in on it. But you can see the different options. And right now we have sum. You can't see it off the screen a little bit. But if we change it to average, and I'll zoom back out here, with average, it's now going to show us the average. Now, since this is money, how many decimals do you think I'll use? And there's 2 options. This one, again, we did one earlier today, that's money. But since this is money, how many decimals do you think we'll use? 8 decimals, 1 decimal, 2, 3, 0. I'd say there's 2 possible answers right here. So now we're changing the decimal formatting after we've selected our y and converted it to averages. So how many decimals do you think we should use right here? Who has a guess on the decimals that would be appropriate? I'm going to go over to home, And here's the increase, decrease decimal button. This is how you increase or decrease decimals. What would seem like an appropriate amount of decimals for this? What would seem like an appropriate amount of decimals? Sometimes I get afraid that we might not be streaming if no one answers questions. I'm like, am I streaming on the internet? Are we here? How many decimals would be good? I am stuck. Let's for 20 points. How many decimals would be good? I'm going to go with this if no one is. 2, HDT, saving us here again, 20 points for the chat. I think 2 decimals, since this is money, would be excellent. Thank you, Kirsten, right there. I think we're on ultra low latency. Let's add 20 points. So 2 decimals seems appropriate to me. And now we're going to do the following. What you pick right here is arbitrary. MuBot's been slow. I feel like something's just weird with everything. Right here, this is arbitrary what you pick for your categoricals, but do not pick something like major. This is going to make it ridiculous. Don't do that. Don't do that. No. I'm going to pick gender. I'm going to put gender here. And then I'm going to go relationship status. I'm going to find this interesting. Now, you could look at this table. It's a pretty large table. And I'm going to show something that some people have noticed. We right now do not have something in this group. If you see blank, please remove blank. This is a possibility, but if you see blank, please remove it. Just a quick note, if you see blank as one of your options, please go to the filter. And I'm looking at the filter right now. It's this button right here brings up the filtering option for this. If you see where it says blank, remove it. Now, this is not blank. That is just a blank. So this area right here is not a problem. What does this represent? What does this mean right here, since I see right here in this box where it has widowed and it has male. I was trying to get it all on one screen so we can see it nice and big. We have male going right here, and we have widowed right here. What's the deal with that not having a value? Why does that not have values? Which we might mention this. It'd be good to mention this in our write-up once we make the pivot chart for it. Why does this have no value? Why is it incalculable? And if you're in 320, we'd have a special thing for this. We'd put capital NA right there. So in 320, we would say that that's NA. The data for that is missing. It does not exist. We do not have data for anything there. There is no mean for this group because there's no values for it. So we've created a pretty decent display right here, and I'm actually interested to see how this goes. I'm actually going to flip it, I think. I think it'll look better flipped. I'm just switching the variable positions, and I think the graphic will look better this way. We're going to go here to, right here, pivot table analyze, and we're going to put in the pivot chart. And yes, that is the way I wanted it to look. And I'm going to make a few small changes first. These are nicety changes that you can do if you're doing the same one I'm doing. I'm going to move this variable. Wow. Oh, there it is. Really right as I move. Wow, I just can't get it today. Let's zoom in a little bit. You have to find the crosshair. There it is. I'm going to put single up here at the top, and I think that fixed it. I wanted single to be at the top because this is kind of maybe how you move through a relationship, and wow, it does sort of show it. I like it. I like what this is showing. Does anyone notice a trend in this data? Does anyone notice the trend? And maybe if I show you the numbers down below, you'll notice the trend that I'm kind of seeing. What trend do you see on how much people are willing to spend? And let's go add in extra things by going here to pivot chart design, going to design elements, and let's add in a data table. And the data table we're going to add in is going to be below. Let's put in the keys. And then we need to add in our titles. We're going to add in access titles, both access titles. We're giving it context here. We could fill those out. And we last but not least need a chart title. We can kind of work with the sizing of this to get the way we want it. We're not going to use this in the background, so maybe people might want to move this over, and we're just going to focus in on this right here. This is where we're going to take our screenshot or copy paste this. And I do notice something pretty interesting. I need some people to help me out here. What do you notice about this graphic? What do you notice about the relationship right here? And someone was mentioning, oh, wow, that's pretty cool. And so I wouldn't add this. I don't know. Someone mentioned this morning. I don't know. It's like a 50-50. But it points to what I'm seeing. So great job, person who mentioned it this morning. I think it was Alexander mentioned it. He mentioned adding a trend line. He's like, I love adding trend lines. And I was like, hey, If it helps you better understand it. And what did you notice right there as I added that trend line? Which I wouldn't add it unless, yeah. I'm just really afraid someone's going to add extra things they shouldn't add and the grader's going to take off. My advice to you is to not add a trend line because the assignment doesn't require it. It's only extra. I would suggest not adding it. What does anyone notice about this graphic? What do you notice? Who's willing to spend the most for concert tickets? So we're looking at how much people are willing to spend for concert tickets. So I should probably write these titles in. So average price willing to spend. Sure. Willing to spend for concert tickets by gender and relationship status. Oh my gosh, that's the longest title ever. Let's go down one font. Oh, such a crazy title. And then right here, prepared by, let's put it in bold. Prepared by, it doesn't have to be in bold. Prepared by Brian Stevens. And then we go right here. What are people noticing? I need help analyzing this. I don't know what's going on. This is relationship status. And then this is average most willing to spend. Generally, women are willing to spend more for concert tickets. So let's take a look. Yeah, you're right. Generally, especially here with the dating casually, women are willing to spend more. There's just the engaged or married. Yo, Brian, just popping in. Quick question. Can I just copy paste the graphics into the Word doc or do we have to screenshot them? Yeah, you can. Watch this. You ready, Om? Great question. Om, thank you so much. Just popping in. Good question right there. Boom. Graphic is now in the Word doc. And then I would mention this, like HDT's talking about right there. With the exception of the engaged or married, women are generally, and look at this. And one big thing right here, watch out with this text. Do you notice how it looks weird right there? I would do this. This is not good. A grader could maybe count you off points for this. Does everyone see this? You don't want this to look like this. Engaged, married. You want to just grab it a little bit and go like this. And that looks better. So epic. You're welcome, Om. Always glad to help out. That's why I love drop in, ask the question, give you some help right there. Make your graphic look nice. Notice if there's anything weird. Like I'm such a perfectionist that I'm going to want to change this just a tiny bit and make it look like that. That would have not lost you points, I don't think, but I think with this wrapping you could. Exactly. HDT, great comment right there. Let's throw another 20 points to the chat. This is what I like to see. Chat's just answering all the questions for me because I don't want to do it. I'm just kidding. Chat's doing an amazing job right here. Widowed does not have any males. There's no males who are widowed, so we don't have any information on that. And we generally see that women are willing to pay more, with the most drastic difference between the dating casual who are willing to spend $191.58 on average versus the males who are willing to spend at most $112. I mean, that's a difference of almost $100. This is what I'm going to include in my write-up. We do see that the smallest difference is between men and women who are single, where the single ladies are willing to spend $220.45, and the single men are willing to spend $218.91. Generally, as someone progresses through a relationship, they're willing to spend less and less. This is maybe some sort of age-related variable, but noticing when we get to the engaged or married individuals and the widowed individuals, the men are willing to spend $128.75 versus the women who are willing to spend $77 and the widowed females. But here's the thing. Widowed females, if I'm to guess, we might literally just have one individual in that group. This is Stat 1 students. I'm not saying Stat 1 students can't be widowed, but my guess is that if we go over here to the count of it, we might just have one individual. This group is just one person right here. And you can see the counts of the individuals right here for each group. So this is the counts of individuals now. We could change the graphic to the counts of individuals. But you can see that most people in Stat 201 are single or dating exclusively one person. So these are smaller groups, which are going to be more prone to outliers. So if we were to also look at the maximum, which is a way to look at outliers, let's go here to max. Someone said they would spend $10,000 for a concert. There was a male who's willing to pay $10,000 for a concert. And what's super cool about all this, what's so great about the way Excel does this, is I can go over here, or I might actually need to add it. Let's go over here to, I'm going well above the assignment right now. We could go over here and say, you're willing to spend $10,000? Really? Well, I'm going to go over here and I'm going to remove these people who said they'd pay more than $1,000. So I'm removing all those. Don't go out and do this, but I now just removed all the people who said they'd spend more than 1,000. And don't do this. You don't need to do this. I know that's the thing, HGT. At that point, and I would acknowledge this, I would say, and I'm going well beyond the assignment right now, but I would say I don't think these people are really willing to spend $10,000 for a concert. I have removed them from my analysis. I'm only allowing people to say up to $1,000, which I think is more reasonable. And now I'm going to look at the averages between the groups, and we see the following. And we do see now that females, except for the married group, females are beating out the males in all instances. So maybe males were more likely to put in a joke answer. Who knows? I mean, maybe males, that person who said they were willing to spend $10,000, maybe they're like, I did it. I saw Justin Timberlake live for a 10-person concert that was $10,000 a ticket. Maybe, I don't know. I mean, tell Justin Timberlake $100,000 to do 10-person concert, he might do it. I mean, how cool would that be to have like a concert that is like you and 9 other people? Would you pay oh my gosh. Sorry, everyone. Would you pay $10,000 for that concert? What if it was like, I don't know, I'm just, see, my artist would be totally different. The concert is Elton John with it's a 5-hour concert with Elton John, Blackpink, and Beyonce. That's the concert. Elton John, Blackpink, and Beyonce. It's $10,000 a ticket, and 100 people get to go. No, it's the concert is $10,000 a ticket. 100 people get to go. Elton John, Beyonce, and Blackpink, and they're like doing duets and they're singing songs. Blackpink is dancing while like Elton John's playing all his songs. Beyonce's doing like some lead vocals with Blackpink. Like it is the concert of the century right here. I don't know what concert I just made up. $10,000 a ticket. And then 100 people get to go. Exclusive concert. So yeah, is this assignment making more sense as we just make some jokes here? Is this assignment making more sense? Would people know what to write up right here? I can't reiterate enough that when you do this, mention the values in your write-up. I put as many exclamation points as I can right here that you need to mention your values. Number 2, you need to, what do I always say? Mention the highs and lows. I try to be consistent in the advice I give. Mention the trends in the data. But I can't reiterate this enough. If you're not mentioning the values, you're going to lose points. And I see that, I always look over what students do. Whenever the grading comes in, I look at what students do well, and I look at what students don't do well. And then each semester I try to give advice. And it's literally like patching holes in a ship. It's like you patch up one hole and another hole opens and you're like patching up this hole and you're like, okay, wait, now I got to give advice over here. I got to give advice for this. I got to do advice for this. And you only have so much time to give advice. So literally this is the cliff notes of advice. And that's probably where I see students losing the most points as of now. How are we doing on this? I think 320 had some questions. 320, how you doing? Who has questions for 320? I feel like a little bit of music. I'm really digging this song lately. It's very chill. There we go. It's piano music. Can't go wrong with piano music. Ben Folds. What else is another good piano artist? It's only Ben Folds, right? Elton John, Ben Folds. Who's the guy? Task 5 and Task 6. You got it. As we listen to some piano music here, between sessions, let me go to space. That helps me know when I hopefully space background's not broken. Thank you, HGT. So good to have you here. Let's go look. I feel like we should have... Ooh, people have submitted their... Someone submitted their assignment 3 report. I need to look at that. I need to see how they did. I really like this song. It's just so chill. Because definitely how the person did will let me think through like what advice I should give. Okay. Let's go take a look at this right here. We are coming back. Back down to earth here. All right, back down to earth. Here we go. Okay. Here we are with task 5 and task 6. I need to mark down the video. Okay. Create a visual display for a quantitative variable of your choosing. Briefly describe the shape of the distribution. Stat 201, shape, center, spread. So what is a visual display we could do right here, HTT? I know I always ask these same questions. How exactly do we know if our knitting makes sense? Feel free to send me it. It should just look like a report. It's going to be a very kind of technical report, but feel free to send me it and be like, hey, Brian, does this look right? Am I on the right track? Is this what you want? And we're probably going to grade this one a little bit nicer, but feel free to send me and be like, hey, Brian, is this what you're looking for? Histograms, you are right. Histograms is one of those variables. And so where's my variable screen? All graphics, here we go. Histograms is up there in the top corner, which is where we have univariate quantitative analysis. So histograms, box plots, stem and leaf, dot plots. And what's really great about this is if we have our variable, I need to go put in a sample size first. Please start this assignment early. Some people are going to be starting this like the night it's due, and they'll be like, it doesn't work, it doesn't knit, everything's broken. And hopefully, a few people have emailed me and we fixed their problems in seconds. You get stuck for 5 minutes, you email me. It's the way it goes. Because with coding, it can be one of the most frustrating or fulfilling things. And at the same time, it can be like frustrating and fulfilling, like literally in the same moment. So let's go right here. Let's create. This is in the eval equals false. Be very careful. If you put things inside of here, it won't evaluate because this is not going to be included in your report. So when we go down to here, we're going to create the visual display right here where it wants you to create it. And let's go ahead and go to my sample and let's use variable. We can do any of these. Let's go to height and there's the vector of height. And what's really cool is the following. You can get a stem and leaf like this. I would probably not make a stem and leaf, but what do you notice about the shape of this? And what do you notice about this? What did someone report right here? So we should know decently how to read a stem and leaf. And that's like the one, look at these, like these one or two random people. That's so interesting how few people do this. I'm actually shocked we have so few. But what did this person right here report? And what did this person right here report? It's a little, there might be some bimodality because we might have the mode for males and we might have the mode for females. There's a strong mode inside of here. And this is not, let me remove this histogram because that's not the same data. I could show you the histogram too. Let's bring up the histogram. All I have to do, what do I have to change this to HDT just to make a histogram? And this is why coding's so fun. I love it because you can just change that stem to what? Like stem makes a stem and leaf of our data. And then I can just change this instantaneously to something else and boom, it's the histogram. So how would I might even do a trick right here. We can get all three on the screen at one time. What would I change that to make it a histogram? What would I change that to make that a histogram? So I've just got my vector of data I'm working with. Literally, if anyone's wondering, this is just data right here. It's just a bunch of numbers. And to think about it, you're just looking at these numbers. That's what we're dealing with. Just turning all these numbers into this graphic right here. Hist, nice job, HDT. I feel like I'm on a longer delay lately. I need to look at the delay on YouTube. And I need to know this command. Where's my like coder friends out there? Like Brian. I always forget the command for this. No, that's not the command I'm looking for. I'm looking at a command really quick. It's the param. There it is. No. It's par mflow or something. It's coming back to me. I just don't use it nearly enough. Par mflow. 2 seconds. This is from me. Par mfro. That is it. Par mfro. Really? And it doesn't do that? And then concatenate. We want 2 columns. 1 row, 2 columns. Cool. Okay. Okay. Be very careful doing these things I'm about to do because now check this out, HDT. When I run this, we can make side-by-side graphics. So what I wanted to do, and you could screenshot these if you wanted. I could put it on top of it. Is it not like the box plot of that? Oh, box plot. There we go. And then, there we go. And then let's put the stem and leaf over here. Why am I showing all of these graphics at the same time? HDT, and let me vanish off the screen. What am I trying to show you here with all these graphics on the screen at the same time? What am I trying to show you here with every one of these graphics on the same screen at the same time? What is the point of this? What is the instruction of this being on the screen right here? What is the point of what we're talking about right here? There's a concept being shown here with a histogram, with a box plot, and with a stem and leaf, where all of them use the same vector of data. There's a concept we should know instantaneously about histograms, box plots, stem and leaves, and sorry, dot plots. No one cares about you. So, and Macy, great job right there. The shape is, and look at this. Which of these shows us the shape the best? This is 201 review and 320 review. Which of these is easiest to see the shape in? Which of these is easiest to see the shape in? So let's ask 3 questions. They're all quantitative univariate. Perfect. So the easiest to see the shape in is going to be 2 out of the 3 of these. Which of 2 of 3 of these is the easiest to see the shape in? The histogram we can see the shape in, and also the stem and leaf. Does that make sense? So we can see right here, there's a little bit of outliers or some more extreme values, and we can see the uni, maybe slight bimodality to it. What does the box plot excel in? 201 question and 320 question. Down here we see this, the min, the Q1, the median, the Q3, and the max. What does the box plot excel in showing us? So the box plot, which is an okay thing to show, but the box plot would excel in showing us what? We might be able to see outliers better. Good point right there. We can see that these low points right here are registering as outliers. These 2 observations right here and right here are registering as outliers. A little bit better at seeing these are outliers. And also seeing the min, the Q1, the median, the Q3, and the max is the what? I just said 5 numbers. So what is that? The 5 number summary makes it. You got it. So, and I'm going to do one last thing right here because I think I want to make this look a little bit better. The pair and flow, be very careful with this. It changes the way it graphs it. If anything's ever broken, please email me. Let's put the box plot up top. Ooh. Oh. Horizontal equals true. There we go. Ah! Okay, let's do that one. Let's see if I can make it look nice. Let's see how this looks. I mean, what do you think? Not so bad. So now we have our box plot, and you can kind of tell if you trace down. I think the number lines, they're not perfectly aligned, which would drive me nuts. I'd work on this some more, but you can see your box plot and your histogram right here using this. So we're just trying to visualize it. So whatever you choose to include, perfectly fine. There are the graphics you need. Any of those graphics are fine. Be very careful with this command. It controls how the graphic box works over there. So I've now changed it back to its default, which is a 1x1 grid. This is the rows you are making. This is the columns. I don't expect you to do stuff like that. Where would I write the code for knitting? Write it inside of where? Where would you write the code inside of knit it to knit it? Really good question, HGT, right there. And Kirsten, excellent answers. Where would you write the code to knit? So this is area 2. And this is area 1. Let's put area... Oops, I'm way down. Area 2 and area 1. Which of these would you write your code in if you want your code to knit? And you notice you just got a hint right here with this. So where do you write code in this sheet? Do you write it in area 2? So when you see area 2, or do you write it in area 1? Where do you write code that will knit? Area 1. And you notice it's actually giving me an error right now. It's saying this is like an error in coding. It's mad about that because that's not code. What is this portion right here, basically? This is where we can just write anything like a Word document. Does that make sense, HGT? This is just like, you can just literally talk about stuff right here. This is not code. It's just a Word document portion. So that's just, and you could always write that in Word afterwards, but that is a Word document portion. And so anything you type, someone's going to like write that in their report. I'll be like, no. So how would you create the table comparing the mean, median, standard deviation? Yes. So Macy, and then we'll do that, and then we'll hop back here to task 5, HTT. So when you create your table, let me go to where that code is at. That code is right here. Okay, let's look at this. What is the format of this right here, Macy? What is the classic format that we use for associate? There's a format we use, something, tilde, something, comma, data equals, and then your data. This format right here, which I'll delete these in a moment, is the same format you're going to use. Do I know 4 of them? LM. You can use it for plot. And I should know one more. For some reason, it's aggregate also use it. Y tilde x comma data equals y tilde x comma data equals y tilde x comma data equals. And it'll be y first. So just remember it's the y variable first. So we're going to try to understand a quantitative variable. Great job right there. Oh, no worries. It's just practice. Like when you get to 474 and I ask you, you're like y tilde x comma data equals. So we just need to choose a y variable. It's weird that it's y tilde x, right? Because it's like x and y. So it takes a moment to remember it. If you want to make your life easier, put this in your code only one time. It will attach, don't worry, that's a graphics error. It'll attach the data frame, and I've already apparently done it. Please delete things like this if this is in your output. And just, there's so many errors you can run into. Please be knitting, please be trying it, and I'll explain any error you get, but there's a lot of things that can go wrong with coding. Just one little thing breaks, and you're like, what's wrong? A bolt fell off, a nut fell off, and just whole machine exploded. So what does attach do? What does attach do? And then let's show the trick right here with attach. What does attach do? I'm going to detach first. Good. What does attach do? When I attach a data frame, it takes all these vectors right here and makes them available to me at any moment. Does everyone see how the autocomplete is now working? So all of these vectors that are in a data frame are now attached to the global environment, it is called. So if I want to easily use the autocomplete and have access to these, I can attach the data frame. So with them attached, we get the autocomplete right here so we can type them out, and you can see we get the values. But if I detach it, wait, what's going on? If I detach it, we don't get the autocomplete. Does that make sense? Ooh, why are we getting that? X06 class? Maybe it's from another data set? Oh, I can't find it. That's so weird. Why did it do that? Like, I am completely bewildered why it... That's so weird. Oh, it might be... I think it's referenced somewhere else. I think it's seeing X06 class is being used somewhere else, and it's utilizing it. So if I attach it, now this variable or this vector can be grabbed anywhere. So, and it was a slightly different color, so I think it's being grabbed somewhere else. Does this make sense here, Macy, what attach does and what detach does? Detach is then going to remove it from access from the global environment. You would have to go inside the data frame. So if it is detached, like if it has not been attached, you'd have to go here to my sample, and in my sample, same sorts of variables. In my sample, you do the $ and go right here. Does this make perfect sense how this is with it not attached, it's been detached, but if it's attached, you don't have to do the data frame. Good, got it, nice. So what we're going to do with it attached, it just makes our life easier, is we're going to put Greek right here because Greek life is the X variable we're going to use to analyze these. And we're then going to pick a quantitative Y variable. Yes. Yeah, to find the old lecture videos, really quick on that, go to your class and go to the Watch Class Live button. Go to the Watch Class Live button and go to the Open the New tab right here. So Watch Class Live, open a new tab, and that'll bring you to it. Great question right there. Thank you, Parker. And so now, what quantitative Y variable do you want to analyze, Macy? What quantitative Y variable do you want to analyze? So you can just say X anything. X, like, you can't say X20 because that's categorical. You can't say X30 because that's categorical. We'll get mosaic plot if we do that. Like I'll just show it right. Oh no, we're not doing associate. So we want to analyze the means and the medians for these, and then I'll make this table look nicer. What quantitative Y variable would you like to analyze? Just say X, I don't know. X07, let's take a look. GPA, ooh, interesting one right here. Okay, so we're going to put right here X07. It's going to autocomplete because we have it attached. That works totally. Great answer right there. It says object Greek not found because I did not run the following code, and that creates the Greek variable. This creates a column called Greek. I could have alternatively called this Greek right here, and it would have worked right there. Either way is fine. I just wanted to call it Greek. And the reason I wanted to call it Greek is because, and that's why I call it right here, this variable is called Greek because I wanted this to say Greek, not XO. Now, there's something I've been helping people do because here's the table. Does this make sense, Macy? Great job, Mubarak, right there. Does this make sense what this table is showing you? It's showing you the mean GPA for people not in Greek life, the mean GPA for people in Greek life, the mean GPA for the median GPA for people in Greek life, the standard deviation in not Greek life, the standard deviation in Greek life. What's even more awesome, which we don't do, is you can actually add in other variables and you can actually look at multiple groups. So now this is a 3-variable display. And this totally works. Don't do the 3-variable display. But now you can look at female not Greek life, female Greek life, male Greek life. And notice the big difference right here. Females have a bigger difference. And so you can just add more variables in, which is super cool. It's just like, oh, let's add in a 3rd variable here, and let's look at this y variable over these other 2 variables. Aggregate's a really neat function. And so now, here's how we make this table look nice. You ready to make the table look nice, which is not required. These the not required parts, and I'll even put this in the chat. So here's how to make this table look nice. Save it into something called tab. Does that make sense? Once I've made this, I'm just going to assign it to this. Does that make perfect sense, Macy, right here? I've just taken it, and I'm going to create an object tab. If you watch my global environment now, what's going to happen when I run this? When I run this, it's just automatically going to create what? We're just going to see right here. Yep, awesome. Great job, Macy. We're going to see tab. There it is up there. It's a data frame. It's treating it like. That's so weird. Because when you write down here, you get the following. Whoa. And that's why it's saying to me, which really drives me nuts, that it only has 2 names to it. So here's what we're going to do. We're going to do the following. We're going to fix it. We're going to fix these names so they're easier to read. We're going to go right here and we're going to go to names of tab. With the names of the tab, we're going to concatenate a names vector, and we're just going to put Greek right here. I'm doing it differently today. And then we're going to run tab. There we go. Here's the code in the chat. And you know what? I'm changing it to this. So I've just changed the code a little bit in the chat. There you go. What does this do right here? Who can explain what that little bit? I'll zoom in on it. Who can explain? Then we're going to do task 5 next. Sorry, HGT. Thank you, HGT, for hanging out. What does that little semicolon do right there? What does that semicolon do to my code? So what does the semicolon do? I just changed it. I ran the code a different way, and then I put a semicolon right there and attached that to the end of it. Which I guess there might be another way to do it. There's like all these different ways I learn over time that I forget. And everyone's like, oh, just do this. So while everyone thinks what that semicolon does, who can explain 20? Good. Thank you, Macy, for answering right there, even if you're not sure. So what semicolon does is it runs multiple lines of code. So if you have here like 5 plus 5, and then you also want to calculate 5 times 5, you could run both of these lines together as one line of code by putting a semicolon. And so semicolons let you run multiple lines of code. It just starts a new line of code, but you don't have to go to the next line. Does that make sense? So instead of running them as individual lines, you could take a line of code and append it on the end. And since I'm just changing the name of the table and then I'm displaying the table, I just put a semicolon. It would run the same way if I did this. It's just on a separate line. Yeah, that's so weird to me too. This started happening today. Mubot sees it sooner. Yeah, the weird thing is I'm getting chat slower than the video. Yeah, I don't know what's going on with like YouTube or my streaming or something, but we had streaming issues at the start of the week, and then like I need to see if other streamers are having weird issues. I need to find a YouTube Reddit thing and be like, hey, what's going on, YouTube? What's going on? I mean, if things get weird on YouTube, I'd be like, hey, everybody, we're totally streaming on Twitch now, 100% Twitch stream. That'll be an interesting semester if I switch to Twitch. We understand what this does right here. Let me see if this works. I think, nope, doesn't do it. Unless, nope. Well, you see, this does print the vector. See, it does do that. If you put this around this, it prints the vector of what we've concatenated. I just want it to do, yeah, so it does kind of do what I thought it would do. If you put parentheses around stuff, it shows what you've done, but I just want to show this, which I can't get it to show, which, bummer. I don't know, I was just trying to make it an easier line, but it works. There it works. Does this make sense how to read this table and what's going on with this? We have the Greek life. No, we have the Greek life. Yes. And one last thing you could do if you really wanted, is this where it got mad last time? It is going to get mad right here, but here's the switch. I think someone was doing this and they had issues. Please tell me if you have issues. Options is usually set by default to 7. We're going to set it to 2. Then we're going to print our table after setting the options, and there's that. And then we're going to go back here and set the options to 7. This just controls the digits. I figured that out thinking about how to resmart our outthink R. So you can change the digits kind of globally in R. So rather than, because that table has text in it and it has words, so it's getting mad. Chapter 5 quiz, yeah, we'll do that next year, Ben. You got it. Which one are you working on? We're going to do HD's question, HDT's question, and then, so let's look here at task 5. Okay. So now we're doing this. We talked about the visualization, create the table. Oh, so we're doing it. Part of the code. Oh, well, I'll be. If you have issues talking about the shape center spread, let me know. Task number 6, let's talk briefly on this. This is actually a good review for chapter. You know what's so funny? I want 201. I want you, 201, to tell me what we are about to view. 201, I need your help. Create the association output for the quantitative Y you choose. Use the QQ plus this side. Okay. So let's go right here. Let's make a big space for this. Let's go associate, GPA, $, XO. We'll find it. Where's Greek life? There's Greek. I guess we called it Greek. Data equals my sample. Let's compare the measures to center, comment on both statistical practical significance, quote the relevant values, and make sure to put in a seed. Okay, that should do it. Okay, 201, I need your help. Every 201 class has covered this. Every 201 class has covered this, and let me do an additional output for this. Please work today. Where was it? There it is, GPA. There we go. 201, I need your help analyzing this. Send it to me, HTT, and I'll take a look. So 201, 320, this is something we should know. Ben, look at that. You're helping out 320 right there. Let's throw some 20 points. Ben helping out 320. HD and Macy, HGT helping out. Everyone following along. What's going on with this graphic? And go into detail. What's going on with this graphic? And go into detail. This is whether or not it is normal. And is it normal? Whether or not it is normal and is it normal? So if you look right here, here's the red line indicating normality, and here's our data. And there's the red line indicating normality. It goes through it, and then here's our data. So this is normal. This part of it follows the normal. That deviates. This is more of a deviation than I like. Ben, still, great answers, Ben. This up here, see, this is good practice. There's a good bit of outliers up here, and then there's a good bit of outliers down here. So we're going to see outliers on the low and the high side. So if we look at the histogram of this, let's just change this to hist. If we look at, oof. Does that look, Ben, does this look normal here? And do you see the extreme low outlier? Does this look normal here? And we could change the bin widths. Exactly, this doesn't look normal. Hey, Brian, good to, oh, Mohammed, so good to see you. Anytime, Mohammed. We met like do we meet during the summer via Zoom? I remember meeting with you, Mohammed. So good to see you. And Mohammed took 201 my last semester before I started teaching on YouTube. Mohammed was up there on the 4th floor with us and with our Mohammed, and then Mubarak's in our class right now. Mubarak emailed me and he's like, do you remember me? I was with Mohammed. And yeah, I know. And I'm like, of course I remember you. Come on. I think you guys sat on the left, right? It was a circular. I miss you guys. Miss seeing you guys. Like, of course I remember you guys. So when Micah was in the class, everyone, yeah. Do you remember me? I'm like, hey, Mubarak right there. There we go. I think, yeah. I was like, of course I remember you. Come on. Why would I forget you guys? Come on. You guys are so much fun. Like, I miss it. I like teaching online, and it really makes it to like, when you guys talk in the chat, guys, gals, everyone knows this. You guys, because I'm from New York. Let's see right here. This is review again. So this histogram looks skewed. Now this QQ plot looks how? How does this QQ plot look? Straight or bent? Does this look straight or bent? Does the QQ plot look straight or bent? I like Mupar. Let's throw people some points here. Does it look straight or bent? And then we're going to do chapter 5 for this. It looks bent, which means an indication of non-normality. Now here's the big question. When we test this, will a p-value be above or below 0.05? The null, here's the hint, the null is data is normal. The alternative, which I told one class about this. No, I hate telling one class. Data is not normal. So the null is that the data is normal. The alternative is that the data is not normal. Ben, you are completely right. The p-value is going to be low because we're going to reject normality. The p-value is very close to 0. There is good indication that this is not normality, and all of this extra work we did is summarized for us right here with these plots. And what do you notice? Oof, I don't like the way that looks. What do you notice about these QQ plots right here, which are called normal probability plots? They're QQ plot, quanto plots. What do you notice about these? Do you see the bend right here? Do you see the skew in the data right here? Skew in data here, outlier, some sort of bend. Now, what does this mean we are going to analyze for these groups? What will we analyze for these groups? And 320, this assignment is moved back till next week. I'll send out a more formal announcement after class today. What would you analyze for these groups? And then we're going to go to chapter 5 for this one. What would you analyze? And this is a 201 question also. What would you compare with these groups? What would you compare between these groups? Since we've said the data is skewed, what would be the proper thing to compare between the two groups? Nice job, HGT, the medians. We would compare the medians because the data is skewed and has outliers. Due to the skew and outliers, which also show up in the QQ plot, it's really where we should look. The not normal one is exactly bend because the normal one's going to be means and the not normal one's going to be medians. Let's go ahead and take a look at this output right here. And so hopefully if you're in 201, this may be giving you some hope. Are the differences between the medians statistically significant? Are the differences between the medians statistically significant? Are the differences between the medians statistically significant between these groups? Are the differences between the medians statistically significant? Are the differences between the medians statistically significant? So no had a median of 3.345. Yes had a median of 3.2. Are the differences between these groups, which are shown right here, are these differences statistically significant? Are those differences statistically significant? No, you are correct. And why no, Macy? I'll give some hints. Why no? You are 100% correct. Excellent answer, Macy. Why no? They are not statistically significant because... Ben, you're so close. Add an extra 0 right there. Exactly. Because the p-value is greater than 0.0. No, Ben, you're fine. Don't worry about it. Don't worry. This is how we practice. The p-value here is about 0.05, which means these differences you see between the medians. Let's interpret this. Here's the interpretation of the p-value. These differences we observe would occur about 11.4% of the time or a difference more extreme. This is an interpretation of a p-value. Mubarak, nice answer right there. The p-value of 11.4% tells us that these differences between medians would be observed by random chance about 11.4% of the time or a difference more extreme. So do you think these differences we observe here are possibly just our sampling variation, that maybe one group just had people a little bit higher and one group had a little bit lower, and maybe this is just random differences, that there really is no difference between these two groups? Does that seem possible to you? Like right now we don't have enough evidence to say that there is a difference. It's like, well, I mean, there's a difference, but it doesn't seem like the difference is really something significant. It could just be random differences among individuals, that maybe we got a few people with high GPAs and a few people with low, that we need a bigger difference to suggest that there is a true difference between these groups. And that's how I would talk about to someone. If I were to talk to a non-stats person, here's what I would say. So pretend you've never taken a stats course. Some of you might say, that was me a month ago. So if you've never taken a stats course, I would say we have Greek students and we have non-Greek students. We looked at their GPAs and we looked at kind of where the middle person was at. Like, where's the kind of typical person because the data is skewed. We don't want to include the outliers because they're going to pull the data in a direction. So we said, okay, let's look at the medians instead of the means because the data has a not normal shape to it. So medians were analyzed here. And when we looked at these differences in medians, what we saw was that the difference in medians might just be due to random chance. So this difference right here that we assessed has a probability of being by random chance of 11.4%. So I think maybe the differences we see where the non-Greek life has a slightly higher GPA of 3.345 and the Greek life has a GPA of 3.2, this difference right here, do I think it's a real difference? Do I think there's something going on here or do I not think something's going on? What do people say? This difference right here is something real or I don't know. I don't have good evidence that that's real. Do you think it's real or not real? And then I'll show you one that's real. Hint, hint, hint to the answer. Did someone ask a question I missed? Did I miss something, HGT? Do you think this difference is real or not real? I think it's not something. Do you want to see a real difference? Let me show you a real difference right here. Let's go to height and let's analyze gender. Do you think the difference between males and females, nice job, Ryan and Kirsten right there. Do you think males and females have a significant difference in their height that would not be due to random chance or unlikely due to random chance? Well, here we go with the graphic. Here's the difference between males and females with their heights, and look at these p-values. Now, once again, we're going to look at the QQ plots right here, and we're going to see that there is some non-normality to this. It's a toss-up to, you got this. You see these outliers down here. It is a little more normal, but we do have extreme outliers down here. I'm leaning, it's possible to use means here. Does everyone see why I'm saying it's possible? Would you want to use currency or accounting? HGT, I'm unsure for your question. Can you rephrase it? Does this make sense right here to everybody that right now I'm thinking I might use medians because it doesn't follow the red line? Does that make sense how I'm picking means or medians? Who's with me on that? Ryan, Kirsten, Macy, HDT, and 201. Does everyone see that? I'm like, well, it doesn't really follow the red line really well, so I think I'm going to use medians. Does that make sense? I'm going to use medians to analyze this. HGT might be in the past. Yep, got it. So with this, we go over here and we look at the medians, and what do you notice is the difference between males and females for the median height? The median height for males was what? Nice job right there, Macy. The median height for males was what? It's a totally different analysis right now, but if you're talking for 201, either's fine, either's fine. I think you're talking for the pivot chart. Either's fine, it's money. As long as you're doing a money variable, either's fine, HDT. If you're 201, you're amazing. Wait, are you 201 or 320? I thought you were 320 because you asked past 5, right? I might be in a dream right now. I don't know. So what is this difference between males and females? What is this difference between males and females right here? So here's the medians. We're just analyzing this output. You can see here the box plots, the histograms, the QQ plots for normalities or normal probability plots right here, which deviate from the normality. They're deviating, so that means we shouldn't use the normal techniques. Normal techniques say we should use the averages. Non-normal techniques say we should use the medians. So what is the difference between males and females right here? Males, the 50th percentile for males was 72. The 50th percentile for females was 65. This is a difference of 7. That is what? Yeah, that's what I was worried about, HTT. This is a difference of 7. That is what? So you see, you're here to answer the new question now. This difference of 7 is what? Very what by random chance? Yes, Macy, great job. This difference of 7 is extremely what by random chance? I need to check the latency on these streams. I feel like I don't have ultra low. This difference of 7 is very, 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 very what by random chance? Very likely or unlikely? Nice job, Ryan. It's exactly what I wanted to hear. That's the thing. Because the p-value tells us how likely it is by random chance. This difference of 7 is basically impossible by random chance because it estimated 0. And then this difference right here of 0.145 was possible by random chance. Like this difference in the previous graphic we saw where the differences were smaller, it was very possible by random chance. But down here, we get a difference that is basically impossible by random chance. And we're like, yeah, I think this difference is actually something real Is this making sense, Ryan, as we talk over this? This topic will be covered the start of next week for 320, because today we're doing an activity day. But does this make sense how I say, like, this difference looks to be by random chance? Let's look at the random chance one. This difference up here looks to be by random chance between the medians. I mean, it's rather small, but also the p-value tells us it's very possible by random chance. And you can see they're very, very close. And then when you look at the second one, and you can actually see visually, we'll just zoom in on it. You can see visually that there's a difference in the medians right here. And this difference of 7 inches between males and females, the p-value tells us that this is super unlikely by random chance. So it's like, do you think it's just random that the guys were taller than girls? It's like, no, I think the data really supports that on, the median. Exactly. Just think of it like, if you were to randomly pick your height, would you get this difference of 7 inches between, it's a rather large sample, like 400 something people, that one group would randomly be 7 inches taller with a median than the other group? I think we're going to hop back for the next 30 minutes and do some more 201. I think, where's my 201 at? Chapter 5. Ben, are you still here? Ben, we're going to go back to space. That's not space. Let's go put on some music here. We're going to get chapter 5 started. Chapter 5, chapter 5, chapter 5. Let's do this right here on these Throwback Thursdays. Where's my Throwback Thursdays at? No, we're doing Tiny Shark today. Tiny Shark, are you breaking the stream? You're welcome, Macy. We need regular shark. Did he not make his noise? Gotta show that tomorrow. Oh, not tomorrow. We don't got class tomorrow. Okay, I gotta focus. Chapter 5. My Pearson. Tiny Shark. Maybe we need like super tiny shark. He's sped up to like 150%. I've got like 2 minutes with this song. Just like chill out. You made Tiny Shark? Yep. You remember yesterday people were asking for Tiny Shark? If you ask, like, if people, you have to send me reminders. Like, the best thing to do is send me a reminder, be like, hey, Brian, can you make this? And I've always got like a task list of things I'm working on. Like, I'm working on a Two Brothers thing. I'm working on fixing the background from stopping. I put a post on Reddit. Hopefully someone says, yeah, here's your issue. But I'm always, I don't know, I got a problem. I work too much. I'm always coming up with new ideas. Do I work too much, Tiny Shark? It wasn't that hard to make because I already had the shark. The longer thing was making the shark because I ordered it. I had to green screen it. So I actually like took the green screen footage. So if someone was like, I mean, I don't think they own the copyright to the shark, do they? Do you think they own? Yep. Should we do the homework or the quiz? Homework or quiz? Ben or Jacob, tell me real quick. I think the song's getting closer. Homework or quiz? I've got both ready to go right now. I just need to know homework or quiz, part 1 or 2. You pick. You're here. You pick. While the background just breaks. Come on, background. Do it. Do your thing, background. Quiz. Which quiz? 1 or 2? I'm on quizzes right now. Quiz 1 or 2? You pick. Background break. Quiz. 1 or 2? 1 or 2? 2's more difficult. I don't even know if I can do chapter 2. I'm just kidding. I like 2 a lot. Oh, wrong button. I need to go to the, watch this right in time. Let's go back over. Here we go. Okay, here we are. Luckily, we start with an easy one that I think we can do. I love it, Ben. Nicole's scores on her midterm was a 64. The class average was a 71. So I just want you to tell me in a sentence, Nicole was how many points below the average? So actually, truthfully, we probably need to copy this over. We need to practice notation at all points. We don't want to go too quickly through an easy question. We want to think, what can we learn? What can we learn from this easy question right here? So Nicole's score is the observation. That's the observation. If the p-values for both the median and the mean is about 0.5, which would you do? So don't pick based on the p-value HCT. Look at the QQ plots for normality. Look at the QQ plots for normality to pick which one. You won't pick based on p-value. You pick based on the QQ plots for normality. So if it's normal, use the mean. If it's not normal, use the median. So the p-value won't dictate your choice. the whether the data is normal or not normal will dictate your choice. And so for this is the practice on notation. Wait, observation. Yes. And that is equal to -1. There we go. Does that make sense right there? Great question, HGT. Thank you so much. We haven't quite covered that material yet. That's another good reason to extend the assignment. Just understanding, like, we use the QQ plus to tell us whether something is normal or not. So now we're on to the 68, 95, 99.7 rule. We have here the mean of 28.2 and a standard deviation of 4.8. And if you look at some of these graphics, they're just ridiculous. As in this one right here. What do you notice is wrong about this? Let me repeat those numbers if you didn't see them. A mean of 28.2. Cool. And then a standard deviation of 4.8. What do you notice about this graphic when I say a standard deviation of 4.8? Look at that graphic right here, and I said a standard deviation of 4.8. A standard deviation of 4.8. What do you notice about this? It's supposed to be a standard deviation of 4.8. And the standard deviation is the typical distance something is away, as in 68% of the observations are within plus or minus 1 standard deviation. And this should be a standard deviation of 4.8 according to the way the question's worded. Is it? Is that, when you go up here, is that 4.8 up? I'd say no. Exactly, Ben. Thank you so much, Ben. It is not 4.8 away. So if you look at this one, 28.2, which you should see down here, if we go to 28.2, and we add 4.8, we should get 33. That confirms that this is the answer. The other one over on the other side had a wrong number here. It's too small. So the correct answer needs to be this. In what interval would the middle 68 be? Now we use the graphic to help us out. The middle 68 is between 23.4 and 33. There's the middle 68. 23.4 and 33. About what percent of autos should get more than 33? Now this is where it gets tricky. But a really good thing we have, and do I currently have it up? I don't have it right now. Let me pause this. If you're watching this video and you're from another class, this is something a student made quite a while ago for our class. So I'm going to pull up a graphic, and this is a huge help. Random. So let's pull up the graphics right here for Stat 201. I can also draw this out, but this is the quick and easy way to answer it if you have the following graphic. So here is the graphic on the screen. And take note of this right here. This is the major cheat sheet for a lot of these questions. This is basically a cheat sheet. Screenshot it right now and use this as a cheat sheet. What you would want to do is be able to draw out something like this on the test. Now you might be saying, Brian, I swear this is impossible, but let's do an easy one of it. Are you ready? We're going to take this screenshot right here, and we're going to basically do what that graphic showed us. So rewind the tape and probably screenshot that and see how to do this. It wants to know above 33. So when we look at above 33, we just draw this in right here. Let me reappear. We go right here and we say above 33. How much are all my arrows worth right now, Ben? How much are both of these arrows worth together? And there's a hint right here. How much are both my arrows worth together? Like the combined worth of these arrows is how much data? Because 68 is inside of there, 32% exactly. With 32% total, because it's the outside, there's 68 inside, 32 outside, and then 16% here, and the answer is 16%. And this is nice job, Ben, right there. Don't worry. A lot of people say 34 because they cut it in half. There's 34 in here, and there's 34 in here, between here and here. Does that make sense where the 34 is? Very common error to say 34, because 34 is between 0 and 1 z-scores, 0 and -1 z-scores. It's practice makes perfect. And we can also see the cheat sheet answers right here if we ever want to double check our work. So use the cheat sheet answers to double check your work, and you can see where the 16 is. This has tons of info, and you can see where the 34 is. Probably too much info to start out with. You just want to practice like this and then double check your work. And if you can draw this out, you can get the answer. That too looks like a... Oh, it totally does, doesn't it? My handwriting is so bad. Oh, I'm so sorry, everybody. Let's time travel and talk to my teachers and be like, I'm not going to blame my teachers. It's my fault I can't write. Okay, let's look at this one. Between 33 and 37.8. Ooh, I got it. Let me think. I did get it wrong. Okay. There we go. So with this one here, good to see you, Hattie. We are going between 33 and 37.8. Mubot's been slow today. I'm going to reset the computer tonight and see if Mubot wakes back up a little bit more. 33 and 37.8 is between a z-score of what and what? This is between a z-score of what and what? Like when you look at this is a z-score of this, and this is a z-score of this. So let's z-score this. This is z-score of 0. This is z-score of what? This is z-score of what right here? So you want to put the z-scores on it. We're going to go look at the z-scores. Let's go over here and look at the z-scores for these. So we've already drawn out a good bit of work right here. We go right here. Put in 0, we put in 1, we put in 2. Nice job right there, Ben. Excellent work. And we're going to do the same sort of trick right here. So we're basically recreating the graphic. Because now when we do this, what is the area outside of this? So if 95 is inside, 5% total outside. So 95 inside, then that leaves 5% total on the outside, and that puts 2.5 on either side. Now here's where people usually get confused on this one. Boom, Ben. Nice job. I'm throwing 20 points. Ben's just been amazing job, Ben. Everyone's getting 20 points in the chat for Ben. Just thank you, Ben. That is the answer. Great practice right there, Ben. So Ben's just subtracting those two numbers right there because he's basically saying we're going to subtract off from 16 this 2.5 because 16 would be the area from here over. This is from here over, which is everything I'm shading now. And Ben is then subtracting off that remaining 2.5 to just get that green area. So does that make sense? Thank you. Yeah, thank you so much, Ben. Jacob, positivity, awesome stuff. Does that make sense, Jacob, what Ben did? He said, I don't want, and just to be clear, the 2.5 does encompass everything over. The 2.5 goes out to infinity. It's above 2. It's not between 2 and 3. Make sure to use your cheat sheet if you want to see what the numbers are to double check your work. I guess, yeah, no, we had it better. It's funny, I have it open in so many spots. So here's the cheat sheet right here, which gives you the answers. I know, right? I need to fix that. HD's noticing that. So 13.5 is the answer. Yep, we're right here. Great job, Addy. 13.5 is the answer, and I need to fix Mubot, what he says. Mubot, we need to help you out. And you have so many Mubots, right? Describe the gas mileage of the worst 2.5% of cars. The worst 2.5% of cars is at a z-score of what? Who knows where the z-score is for the worst 2.5% of cars? Who knows where the z-score is for the worst 2.5% of cars? Yeah, if you're watching this right now, Jacob, it's a huge help. And there's an error in this one also. I got to correct it. You're close, HDT. It's not going to be 3 or -3. It's actually going to be 2, -2 rather. And I'll show you why right here. So we're saying the worst, did we say worst 2.5%? And you can see the answer right here with what we've drawn. It's going to be at -2. This is good practice. And we actually used the 68, 95, 99.7 rule in 320. So I promise you the things you learn in 201 help 320. If you learn things in 320, it helps 201. So it's lots of good practice right here. And so the answer is going to be 18.6 as long as it's the worst. Did it say the worst? The worst. So it's 18.6 we said, right? Did we get it all correct? Not today, my Pearson. This is chapter 5. Yep. Is this making sense, Danielle? Is it making sense how we did this problem? We'll do another one right here. This was the empirical rule. This is solving stuff 100% with the empirical rule. Nice. We get to an easy problem now. I love it. Easy problem, quick problem. So now we want to know, this is not a z-score. This is not a z-score. It says, how many standard deviations is it below the mean? What is the formula to find? Just practice in the chat right now Just remember, all you're trying to find is how far is it below the mean. So it's not asking a z-score technically. I mean, it is kind of, but it doesn't want the negative on it. So the formula is, not today, my Pearson. Yeah, I think there is a not today quote. Where is it? Let me find that. Do you guys, yeah, you probably get what it's a reference to. I wish you could search the quotes. I swear we put, if you saw it, you can do it. Might have to add it if it's not in here. Am I going crazy? Oh. There we go. Quote 56. Not today, my Pearson. It's in there now. It has no comment. Oh no, maybe I should add a comma to it. We'll find out. So what we have here is the mean and the standard deviation. It also tells you that up here. It says that the mean is this. So the mean is mu and the standard deviation is sigma. Just so I can draw those really nice and big for you to see. Mu looks like this. That's a mu. And a sigma looks like that. That's a sigma. I just kind of scribble them sometimes like that. So there's mu and sigma, which stand for population mean and population standard deviation. And we often write them in the curve in the following format to stand for saying something is normally distributed with a mean and standard deviation. So that's what the big capital N stands for right there. It is normally distributed. So that is what we have right there. We have a normally distributed curve with a mean, and the mean would go right here, and the standard deviations are the distances above it. So now we want to figure out what is, or how far away, how many standard deviations the observation that is 1,000 is below it. So we're just going to go right here, and we're just going to take and do observation minus mean over this. And that should be 3.18. And it's negative, but it wants positive. 3.18. 3.18. 3.18. There's the answer of 3.18. Pearson followed me into... Pearson follows you everywhere. I will say this. They are I'm really... Like, I'm always thinking maybe we could, like... I don't know. My Pearson's like, what, you're not going to use this anymore? They're really helpful. The 1,000, it's asking right here, a good question right there, Addie. It's asking how many standard deviations is this below? Does that make sense, Addie? It's asking how many standard deviations is this below? So I compared it to the mean right here of this. So I'm comparing the 1,000 to the mean of the distribution. So to just show the mathematics again, 1,000 would be the observation. So the notation for what 1,000 is the observation. 1,000 is the observed value. So we're asking an observation of 1,000. So we're doing observation minus mean over standard deviation. And this will get you the z-score. Do remember that it wants the positive. So I'm not going to put absolute value on that. Thank you, Addie, so much. 20 points. Addie popping in, asking a question. This is what we call positive reinforcement in psychology, because I'm always afraid someone's watching and they're like, I don't understand. So I appreciate everyone who comes in and says, hey, how'd you do that? What are you doing? Because that's what makes office hours. It's not just me solving problems. It's like, hey, wait, so where'd you get that number? So which would be more unusual, the 1,000 or the 1,250? Just here's the easiest way to solve this. Which of these numbers is further from the mean? So look at here at the 1159, 1,000 or 1,250, which is further from the mean? Is 1,000 further from the mean, or is 1,250 further from the mean? And you can subtract the differences if you want. While you try to figure it out, I'll just subtract them. If we standardize them, you can just see which one's further. So 1159 minus 1250 is 91 away. Technically, it's a positive difference. And then we just did this one right here. Is that not that? So which one is further away? And that would be the more unusual one because it's further from the mean. And the answer is the one that's further from the mean is 1,000. Now, please watch out. I'll probably give you the points back. It wants a positive number here. I think it gets mad if you put negative. Yeah, it does get mad. Someone's like, Brian got it wrong. I swear I told you it would take. I said it would do it wrong. I've done this problem before. I promise. It's not my first time. I swear. Is it my first time doing this problem, Puppet Shark? Puppet Shark. Puppet Shark. I swear I've done that problem before. Puppet Shark doesn't have faith in me. A forester measured 25 trees. Exciting content we're doing right here. A forester measured 25 trees. He found a mean diameter of 10.1 and a standard deviation of 4.2. And if you look at this data below, we have the 68, 95, 99.7 rule. So with this right here, this one is incorrect instantaneously. It just doesn't even make sense that this is 99.7% of the data. It goes in the wrong order. So we're left with 68, 95, 99.7, 68, 95, 99.7. What do you notice is wrong about this right here? You can see it if I hold it like this. What is wrong about this distribution right here? Someone tell me. You have to say the blank is wrong about it. What is wrong about this distribution? The blank. I can't show it at the same time. I can't point to it. What is wrong? What is wrong about this distribution? There's something wrong. The mean. Nice job, Ben, right there. The mean is wrong. So this is the right one. It has the right mean. What would you expect the middle 68%? Well, let's just review. The middle 68% is within plus or minus 1 standard deviation, and it gives us the answers. So 5.9 to 14.3. Middle 68%. 5.9 to 14.3. What percent would you expect to have diameters above 5.9 inches? So 5.9 inches has a z-score of what? 5.9 has a z-score of what? 5.9 is a z-score of what? What is the z-score of 5.9? What is the z-score of 5.9? Close, Ben. You're super close. And I'm so glad I asked the question. It does not have a z-score of 1. It is 1 standard deviation below the mean. Exactly. Yeah. Like, come on, Brian. Come on. I'm messing with you. I was going to add that in right there. You got it. It's -1. So we know that this has a z-score of -1, and it wants to know what's above it. Now, easiest thing to do, and we'll show this visually right here because we can use our previous visual. It's just different numbers, but we are on this visual, so we can use our cheat sheet from before. Someone might be watching this without... I put marks in these, and I don't want someone to be like, I have no idea how you did that. If you've been watching the whole time right now, you probably know this, but don't worry if you don't know. And these are tougher questions that require a lot of practice. So here's what we do. Whenever we have these problems, we draw out our curve, and we add to it the z-scores. 0, 1, 2, 3. This is now the standard normal. We call this the standard normal because it has these standardized measurements of z-scores on it. So with the standard normal on the screen, I'm now going to go and do the inside-outside trick. If 68% is within here, then what is total outside? And what would be total outside is what adds up to 100. Just so everyone can see right here, when we talk about what would add up to 100, we can say, well, 100 minus 68 is 32. That means total outside is 32. And I keep saying total because that's not what one of those is worth. Now, if you look at these right here, they are symmetric. And since they are symmetric, you got it. Nice job, Ben, in the chat right there. It's both of these are going to be worth 16. Now, it didn't want this answer. The answer it wanted for the question was what percent of area is above here. So now, take a moment and see if you can figure out what percent of area is above here. And all you have to do is travel across these tracks. Like, think of it as like a train track, and you're going to go all the way from here over and add up the area. Probably the easiest thing to do is to realize if 16% is below here, then what would be total above? If 16% is below, then what must be total above? So now I'm just going to kind of make it easier with what we have on the screen. If 16% is below, then what would be above? So it has to add up to 100 again. 16% is below. And I think Ben's got it. You got it, Ben and Jacob. Excellent. Jacob, you're in the asynchronous and you know this and you're practicing this. You're getting it down. Nice job right there. This is 84, which is the answer right there in red. So 84 is the answer, and we just practiced the 68, 95, 99.7 rule. It doesn't hurt to have your cheat sheet. You can't use the cheat sheet during the test, but this right here is a really big help. So there's a nice big screenshot of it. Let's let the screen kind of settle. You're going to go away. So here's a screenshot of the curve with all the numbers broken down. Thank you again to the student who drew this out. They were actually on the dance team, which won the national championship. Had a contest who could draw the best normal curve, and that was voted best normal curve. So really huge thanks to them. I always say that it's students who help other students, because a a lot of my resources have been suggested by students. I mean, I think Ben remembers literally yesterday someone said, you know, make tiny puppet shark. And did we do that? Can't overuse it. Maybe you can. So now we want to know diameters between 18.5 and 22.7. 18.5, 18.5, and 22.7. So here's where the cheat sheet makes life so easy, but you got to be careful. You have to know how to do this. The answer is going to be 2.35. The answer is going to be 2.35. And if you go straight to the cheat sheet, you can just look at the answer and be like, okay, I got two versions open. We're right here on it. We're between 2 and 3. If you notice, we're between the z-score of 2 and 3. And look at this, we're between the z-score of 2 and 3, where the numbers are at, and that's 2.35% of the area. Here's how to get it without the cheat sheet. What is total for my red arrows right now? My red arrows are total what right now? What is the total for these red arrows? The red arrows have total how much? The red arrows are total right now how much? We have the answer on the screen, so we're kind of working backwards. The red arrows are total how much? The red arrows are total how much? Well, now it's 100% if you, how about the total highlighted area? So let me do this. The red arrows are total how much? 5%. 5%, because 95% inside, 5% outside. And so that makes these 2.5 each. The green arrows. The green arrows are total how much? The green arrows are total how much? How much total areas? Oh, no, you're fine. You're fine. I think, Daniel, you're right on it for like kind of where we're going with it. You're right on it because that's how much is between the answer Danielle just said. And we're asking about the green arrows right now. So if you want to answer. Danielle, you answered this. That is 4.7. You are correct on that. Exactly. 0.3. And the reason we're getting that is we're just subtracting this from 100. So we take 100 minus 99.7, which is that number there, and it's 0.3 or 0.03, 003, however you want to say it. We're doing it as percentages right now, so we're going to put 0.15 because that's half of it. And the way to know you've done these correctly is if you go across here, and I'll highlight only these things. If you go across these highlighted paths, how much area should you have? If you've labeled your graphic correctly, how much area should you have? How much area should you have? If you go across any of those highlighted paths, you should cover 100% of the curve. So it looks like we've done everything correctly. And then you might say, well, Brian, why is that area right there that? I'd like for you to look at this. Let's do it in another color. Let's go there. 0.015 and 2.35. What do these two areas add up to right here? What do these two areas add up to down here on the bottom? If you were to go across these, like if you went this way from here over, what do they add up to? And you can see how we get it because we can subtract off the 0.15 from it, from 2.5. What do those areas add up to? Those two areas, 2.35 and 0.15, add up to the 2.5. Do people follow how we solved this? I think this is a trickier one, but is this making sense? I hope people can solve these types of problems. Once again, have your cheat sheet out. I'm going to keep advertising the cheat sheet. So if you're in another class and you don't have this because it's posted on our Canvas, this right here is the cheat sheet, which has the numbers. And then you can see it's 2.35 and you can see 2.5% from here over. So good job. And I know I do each of them slowly. It's good practice. And so we said 2.35, right? Boop. And what percent of trees should have diameters over 18.5? We probably have a good answer for this already, right? 18.5 has this. Oh, we got this. Who here can look at our answer now? And when we look at above 18.5, what's the answer to this? What percent of trees should have diameters over 18.5? This one's super easy. We have everything labeled right here, and we have an arrow pointing to it. What percent of trees are expected to have diameters over 18.5? With this one, we should be able to like, boom, we look at the graph and we're like, oh, we already labeled what percent of trees should have diameters over 18.5. I've got a lot of arrows pointing to it. What percent of trees are expected to have diameters over 18.5? Well, we'll just make it just show that. 2.5%. Exactly, Ben. Great work right there, Ben. And it's just this one arrow. And so that is the answer to the last one. And we should have everything correct. Hopefully I entered in all the decimals. I've done these a lot. Oh, I knew it. I knew it. Where did I write a decimal wrong? Did I read one incorrectly? What did I do, everybody? I knew I went too quickly or something. 34, 13.5, 2.35. Do not round, type an integer or a decimal. Above 18.5. 14.3. This is going to drive me nuts. What did I do wrong? Oh, wait. I see it. Yeah, I see it. I just saw it really when I looked. Yeah. Wow. My Pearson got me today. Yep, I was like, all these numbers look correct. I just did above instead of below. Tell me if you get hit by that. I don't know. You guys know I'm nice about giving points back. I see how these mistakes can happen. I make them all the time. It's possible to just read a question incorrectly and see above versus below. So it's very easy to make mistakes on these. That's why I say not today, my Pearson. It's very easy to misread a problem. So I understand completely if you make a mistake, because I'll make them every once in a while. I just make them to let you know it's possible. I'm just kidding. I do make mistakes. The average score on the stats midterm was a 74 with a standard deviation of 4. Arthur says his z-score is a -1. What does that tell you? What does it tell you when Arthur says his z-score is a -1? What is Arthur telling you by saying his z-score is -1? Arthur says his z-score is -1. And what is Arthur telling you when he says my z-score is -1? Which that's not that bad. You did all right, Arthur. That's okay. That's okay. Maybe, some people, if I took an English test and I was 1 standard deviation below the mean, not saying that's what the answer is. If I took an English test and I was 1 standard deviation below the mean, I wouldn't feel so bad. I'd be like, English isn't my best subject, and I'm glad that I wasn't that much lower than the mean. But we see here Arthur scored exactly 1 standard deviation below the mean. Great job right there, Addie. This tells us what Arthur's score is. What if someone said their z-score was a, whoops, wrong number. What if someone said their z-score was a 2.5? If someone said their z-score was a 2.5, what did they score on this exam? So now it's a more difficult question. If someone said their z-score was a 2.5, what did they get on this exam? You can kind of see the answer. I'll make it more obvious as we do it. But if someone said their z-score was 2.5, what did they score? And this is just the practice we need to know that. And you could mathematically solve it. Here, I'll show you how to mathematically solve it. But with the visual, it's a little bit easier. So they are 2.5 standard deviations above the mean. The mean is 74. And they are 2.5 standard deviations above the mean. So the mean plus 2.5 times standard deviation. That is what we have right here. And they made an 84. Exactly. And you can see visually right here that they would be right here at an 84. So that'd be the observation. And this would be a Y. The person made a score of an 84. Now, that's not our answer. Arthur did all right. Don't worry, good, Arthur. 70. Maybe this is the stats final. And you did quite all right, Arthur. We're proud of you, man. I don't even know who this other person is. Still proud of you. So people with z-scores of 2.25 or above on a certain aptitude test are sometimes classified as geniuses. It's a kind of, I don't know. I have a high standard for what I call genius. I don't know. I think I've met 2 or 3 people I'd classify as geniuses in my life. Thank you so much, Addie, right there. Do we need the David M. Lane for this? Oh, yeah, no, you could view this with the David M. Lane and Mubot. Mubot's really slowed it in. YouTube's just been a little bit weird this week. Don't like that. So if aptitude test scores have a mean of this and a standard deviation of this, what is the minimum aptitude score? So here's what we should think in our head. All we're doing is going up blank and a quarter standard deviations. Let's do this one in our head. You ready? We're going up blank and a quarter standard deviations. So fill in Brian's blanks. From the mean, we're going to go up blank and a quarter standard deviations. You got it, Ben. You got the mathematics right there. So we're going to go up 2.25 standard deviations. So what is 2 standard deviations is 40. And what's a quarter of it? You got it, Ben. There's the quarter of it. So let's show the mathematics just in case anyone's wondering. What we're doing right here is someone told us the z-score is equal to 2.25, and that literally means how many standard deviations something is above the mean. So we take the mean and we add to it the z-score times the standard deviation to get the observation. This will give us the y value, the observed value. So the mean was 100, the z-score is equal to 2.25, and then we times that by the standard deviation of 20, and that equals 145 right there. So that is the observed value. So remember, when you think of z-scores, just realize it's telling you how many standard deviations above or below the mean something is, and that is what we get right here. I think we checked that one. We are good to go on it. A town's January high temperature is 34 degrees with a standard deviation of 12, while in July, the mean temperature is 74 and the standard deviation is 10. Fun times. In which month is it more unusual to have a 55-degree day? Now, this 74 and 55 one's a little bit nice. Let's go grab this information. And to standardize these, we're going to turn these both into whats? To standardize these, to figure out which is more unusual, we're going to turn them both into whats? To standardize this information, we're going to turn them both. You can just say the first letter of it. I'll know what you're talking about. A town's January temperature is this. Let's write this information down in notation format. We have right here, this is the mean. This is the standard deviation. This is the mean. Sure, yeah, color change pen. Standard deviation. And then this is the observed value. We kind of have different groups right here. So what we're going to do is we're just going to turn these into z-scores. So the first one is, this pen is possessed. 34, 12. That's the first distribution. The second distribution is going to be normally distributed. Does it say normal? You can find z-scores either way, but you should only really find them for normal data. And they should specify that, my Pearson. And then we're just going to find the distance that this 55 is away. So in the bottom one, it's observation of 55. We can do better. Observation of 55 minus the mean of 74 over the thing of 10. That should be negative 1.9. And the top one right here is observation of 55, same observation, with a mean of 34. That's a difference of 19. And a standard deviation of 12. No, it is 21. And tell me if I'm wrong, everybody. This should be, oh, don't tell me. It's difference 21, right? So then 9. So 1.75. I could check the mathematics, but please tell me if I'm wrong. It looks like the January has a 1.75 z-score and the July has a negative 1.9 z-score. And so the July is a little bit more unusual. Never hurts to double check your mathematics. I like doing it in my head to see if I can solve them. Just some good mental math practice. Let's check our math. That is correct. Never hurts to practice your mental math. And we are correct. So, oh, thank you, HGT. Let's start 20 points. Thank you, HGT. I appreciate people confirming the answers because I do make errors as shown previously. About the rivets and shear strength, you got it. Let's do the rivets and shear strength one next. We can hop to that question. 1.9 and 1.75. Okay. It is more unusual to have the high temperature of 55 in July. So it is the July one is more unusual, right? Because yes, a high temperature in July is 1.9 standard deviations below the mean, while the January one is 1.75 standard deviations above the mean. Boom, goes the dynamite. Shear strength. Watch it be the next one. That'd be so awesome. Nope. Oh, fill in the blank. Those are so fun. I do mean it. They're pretty fun. Here we go. Okay. This one's a bit tricky. I want you to notice something about this one that usually people don't notice. How many standard deviations does this graphic show right here, Ben? This is where people don't usually notice this and get caught off guard. Like I said, I've been teaching this a while, and I know this is where the mistake is made. How many standard deviations are you looking at right here? This is where the mistake is made because they throw a little curveball at you right here. Awesome, HGT. I'm glad that's the first lag. Oh, so it is showing 3. It's showing the 3 numbers, But these numbers right here from here to here are how many standard deviations back? Man, I hate these lag bursts. I think there might be something weird with YouTube or something or sudden link. I'm literally actually going to get the Elon Musk internet here in a moment. Later tonight, I'm going to pre-order Elon Musk internet. So send me a reminder, whoever told me about that. Yeah, we've been doing 1, 2, 3 for so long that they throw a curveball at you, and then now you're looking at right here. The proper answer is going to be this one. The reason being is because the standard deviation is 40, and it is 2 standard deviations. Does that make sense? Here's 690, and here's 730. This is 0. This is 1 standard deviation. This is 2. And here is the curve right here. It has a mean of 650, and this is 2 standard deviations. I know people are looking at this and saying, Brian, this is the answer, but this is 2 standard deviations. 1 standard deviation, 2, that's the 95%, 2 standard deviations. So you have to go 1 standard deviations, 2 standard deviations, and the 3rd standard deviation would be there. So that's where usually the mistake is made. You're welcome, Addie. Did you get 100, Addie? I hope so. Great work, Addie. Great work. Would it be safe to use the rivets if the situation requires a shear strength of 610? So let's look at our graphic. 610 is going to be right here. So the numbers that come to my mind are 16% below you. Good job, HGT. Good seeing you here. If we were to look here, we would see that 16% of the shear strengths are not going to meet that, because right here is 68, 68 inside, 32 outside, 16 in either hand. So we go right here. What percent of rivets are expected to fall below 730? So let's graph this one out here. Below 730, and let's go right here. Below 730. Below 730 is going to be how much? Below 730 is going to be how much? Well, we know between here is 95. And that means outside total is 5% outside total. So this is 2.5 and this is 2.5. And that means below here is this amount. And above here, which we're not interested in, is this amount. So probably the easier way is not, we could add the numbers, but it's 2 numbers. But what does it look like the answer? 97.5, exactly. 97.5. So we can see that the area below there is 97.5, and that's got it. Did you get this one now, Ben? Did this one make sense, how we're able to graph that out? And we should get it right. Yes, we got it. Nice job right there, Ben. Let's see, do we have, let me look for the multiple choice. We can do this for some fun. Which of the followings are changed by multiplying each data set by a constant? And this will rescale. They're actually giving it away right here by saying rescaling. It's also going to move the center. So let's just do a very small data set right here. A very small data set would be something like, let's go here, 1, 2, 3, and let's do 10. So when you look at this, and can you do the multiple choice Z-score? Yeah. Is it this one? It might be this one. What has changed about this distribution? Let's look at the median of the distribution. Has the median of the distribution changed? Has the median of the distribution changed? Has the median of the distribution changed? Oh, well, then we'll find it. We'll find it here in a second. I would say that median is drastically different. The median has changed. Has the mean of the distribution changed? I would say when you average these up, the mean has changed. Has the spread of the distribution changed? So it looks like to me, every single thing has changed right here. The IQR, these are measures of spread. These are measures of center. They've all changed. Let's see if we can find that other one. Shifting the data by adding a constant to each value does not change the what. So let's try this. You ready? Let's go back to our data that we just had and add a constant to it. So if I were to take this data here, 1, 2, 3, which is just a data set, and I'm going to add a constant to it. Now I'm going to add 10 to them. What looks like has not changed here, Ben? the what of the distribution. So here's two answers, which I'm kind of alluding to. There's this answer, really, my colors. There's this type of answer here, Ben. Or what is Brian alluding to with the green and the purple? I've added +3 to my data. So we'll put +3 right here. And which of those looks to have changed? So we got two kind of sort of answers right here because there's two measures for the distributions we're looking at and we're comparing. So which of those has changed and which of those have not changed? So adding a constant would change this measure for our data. Oh, no, we didn't add +3, we had a +10. What looks like it changed right there? We've got a purple answer and a green answer. And the purple represents a measure of something, and the green represents a measure of something. And one of those has definitely changed. So adding a constant would do what to, it would change one of these. Adding a constant to your data, adding a number right here, which we're exemplifying with a small data set, adding a constant would change the measure of center. So these right here are the measures of center for this distribution. They're actually both the mean and the median. It's just symmetric data set right here. Good to see you, Natasha. We have that the measure of center is going to stay the same, and the measure of center is going to change, and the measure of spread is going to stay the same right here. Does that make sense, Ben and everyone else watching? That you have the same measure of spread. This data has the same distance across it, or the same sort of like spread of the distribution, using the same word, right? Or same sort of distances, values are away from each other. That's what spread is, like how the variation in the data. And then the center, which is where kind of the middle of the distribution is at, the average value or the median, is going to be different. So let's look at the question it had, and then we'll find Ben's. Shifting the data by adding a constant does not change the spread. So median is a value of center, and quartiles are a location, and mean is location, standard deviation is a value of spread. That's the answer. It won't change the spread. The median is a quartile, so quartiles are going to move. Is this the one? A standardized value is a value found by which of the following. So when we talk about standardized values, if you put part of the question in the chat, Ben, I'll find it. A standardized value is found by which of the following. So to find a standardized value, let's look at the formula. Well, we have it right here. The formula is observation minus mean over standard deviation. So it's just the distance that an observation is away from the mean, and then we take that distance and we standardize it by dividing by the standard deviation. It says, which of the following statements is true about z-scores? So yeah, let's take a look. We'll find that one next right here. So divide the value by the standard deviation of the data set, subtract the mean from the value, and then divide by the result by the standard deviation. I think that's it. Cool. Is this, okay, cool. Let's look at this. Which of the following is true about z-scores? A z-score is a measure of how extreme or typical a data value is. Yes. We were talking about this earlier today, and we had some great notes on it. So today, I think I drew it in this one. I thought we exemplified it really well with the following graphic to talk about whether things are unusual. Really? I think sometimes my brain makes up that something happened. Well, I'll be. It is in these notes. 2 seconds. Because we have such a great graphic. I only have like 3 more seconds to show it. And here we go. Here we go. Here is kind of z-scores right here. Z-score of 0, 1. I think it's E. I think it's probably gonna be all of them too. Yeah, I know, right? Here's the common, here's the mild, here's the extreme values. So the z-scores are showing us this is true. A z-score tells us how many standard deviations a value is away from the mean. And we were just showing that literally moments ago with the z-score formula. It's how many standard deviations a value is above or below the mean. That is very, very true. Z-scores have a mean of 0 and a standard deviation of 1. That is 100% true also. You can see it right here that the center is 0. That's the mean. And they have standard deviations of 1. 100% true. Z-scores standardize a data set. Yeah, they put it all to the same metric. And there we go. Does that make sense right there? It is E. That's the easiest way to, that is the correct answer. Oh, we did the Rivet one, right? So we've done this one. Did I put 2 Rivet ones on here? Let's speedrun this one. You ready? Can we beat it in 10 seconds? So this is 2 standard deviations. So it's this one. Oh, we already, yeah, we did do it. Well, that's no fun. Let me group here. This one's similar to the tree one. We did another tree one. Okay, we didn't do this one yet. Suppose your statistics professor, Brian Stevens, reports test grades as z-scores and you score a 1.7. Not too bad, not too bad. Pretty good. That's pretty high. Write a sentence explaining what this means. So a z-score is how many standard deviations. You're welcome, Ben. A z-score is how many standard deviations an observation is above or below the mean. So you scored 1.7 standard deviations above the mean of the class. So you would have scored right over here. Excellent job. That's pretty good. That's like in the top. You're actually in the top, like almost 4% of the class. If we go over to David M. Lane, which I think we have open, I think you're the top 4.7 or so percent of the class. So let's go over here to David M. Lane. They're reporting your z-score, and your z-score is 1.7, so you should be about top 4.6%. So let's go to above 1.7 and 4.6%, 4.5%. So very close. You're the top 4.5% of your class. Excellent, excellent work. You're almost an outlier, almost a mild outlier. That's pretty high. Your friend got a z-score of -2. Oh, sorry. And then the curves are on the normal curve. What percent are expected to be lower than your friend? So 2.5% are expected to be lower than your friend. And how did we know this? Well, one, always have your cheat sheet open. Cheat sheet is super valuable. So your friend was at a z-score of -2 right here. And using the 95 rule, let's go ahead and take a screenshot of this. Your friend had a z-score of -2. And what we're going to do right here is we're going to look at just the part of the graphic we're interested in. So you just want to practice this. And since your friend has a z-score of -2, they are 2 standard deviations below the mean. And then we're going to go right here. And we're going to go ahead and show that 95% is here. And then total outside would be 5%. And don't worry about that arrow. It's a different arrow than what we're using. So I'm going to not trace over that arrow. Truthfully, you can use the arrow up here. There's the arrow up here. And that's the 2.5. And here's the arrow here. That's the 2.5. Now, if you don't have this graphic, so that is the answer. The answer is 2.5. The way to do it as a smaller graphic that's more compact that only shows this answer is to go here and remember that at -2 and +2, you've got 95. So this is the 68, 95, 99.7 rule. 95% is between here. 100%, I got it. Oh, thank you so much, Ben. Great job. You earned that. You got it. If 95 is inside, 5% is outside, 2.5 either side, and we have to memorize the 68, 95, 99.7. Probably going to do a few more questions here to make sure we get as many as we can in this video, because I'm really happy when everyone uses the videos. It really makes my day to know the videos are being used. This one's nice because the IQ test has a mean of 100 and a standard deviation of 17. Narrows down the answer to this one has to be wrong. It has the wrong mean, you notice right here. And then the standard deviation of 17, well, this one has 99.76 wrong numbers. So this is the right answer. In what interval would you expect the middle 99.7% of scores? So we just look. 99.7 is in plus or minus 3 standard deviations, 49 and 151. 49 and 151. About what percent of IQ scores should be above 115 or 151? So now this is pretty extreme. This is an extreme outlier right here. And we've got our cheat sheet, so we can see the answer. There's the answer. So let's not cheat immediately and find the answer that quickly. So with our cheat sheet, I've shown it a lot through the video. Pause and kind of take your own screenshot of it so you can use it. We see that 99.7, and we can use their graphic too, is between here and here. Now we're going to use these arrows to find the answer, because if 99.7 is between here, we're just going to subtract from 100. So 100 minus 99.7, that leaves 0.3 total. We're going to divide that by 2, and that leaves 0.15 here, and that is the answer, also 0.15 here. That is the answer. Whew. And it is above, right? I got one wrong earlier because I said I did the wrong way. Above. Okay, good. We did it. A very small percentage. About what percent should have between 83 and 100? Let's look at the z-scores on those. This is the right graphic, right? Good. 83 and 100 is between here and here. Now this one's nice. With this one, and let me go all the way back to our sheet. 83 and 100 is a z-score between -1 and 0. So when you look at this one, you're trying to isolate the area right in here. And I don't know how many people are watching right now, but think about this. I'm going to do something right here. Look at that 68. And I want you to focus in on that 68. With focusing in on that 68, I want you to see if you can figure out that yellow area. Because now I've total shaded what? I've shaded what? Since we know 68, I've shaded all of the 68. And what do you notice about this and this? It should be, they're symmetric. So we just cut the 68 in half, and that makes each of these 34. Once again, the cheat sheet's huge here. Cheat sheet is great help, but we should be able to derive these answers also and kind of not use the cheat sheet. Cheat sheet is practice, helps us out, but we need to know how to get them without the cheat sheet. About what percent of IQs should be above 134? Well, we have to z-score this. 134 needs to be z-scored. Nice job, Jacob, right there. Let's throw another 20 points. Thank you so much, Jacob. And so... No. So Jacob, what is the z-score for 134? The z-score for 134, which I've just written. If someone wants to tell me why the ghost in my pen just randomly decides to change colors, I don't know. We'll talk to it. It's Mubot probably messing with us. I told Mubot he doesn't exist. That's like saying you don't believe in Santa, and you're just going to incur the wrath of Santa. Look. I said, Mubot, you don't exist. And then that happens. So, you know, craziness. And there is the answer. There is the answer. Nice job, Jacob, right there. The answer is 2.5 on either side. And the way to check your work mathematically is to make sure that when you go across the arrows, you get 100%. The reason we got 2.5 is because we know 95 is between positive 2 and negative 2. And we're going to subtract 95 from 100 then to get the outside of 5% total and divide it in half to get the 2.5. It's the wrath of Santa. You never know what you're going to hear in class. Are we teaching stats? I don't know. We've completed almost all of this. This is a very similar question. Let's do more multiple choice because those are fun. I think we did this one. Shifting data by adding a constant does not change what? We did this one earlier. We've got so many sheets open. So if you're looking for this one right here, it is a repeat question, and shifting the data by adding a constant would not change the spread of the data. So here's the spread in green. I've added 10 to all the values, and the spread is still the same. So any measure of spread will not be changed. Any measure of spread is standard deviation. The other ones are positions in the data or the average of the data. So, and the median is a quartile. It's Q2, so the median would change. I don't think we've done this one yet. We're so close to all of them completed. A company's customer service hotline handles many calls relating to orders. The company's record indicates that the calls have on average this and this. If the companies were to describe, this is a trickier one. Yeah. Let's focus. Okay. If the company were to describe the duration of these calls in seconds instead of minutes, what would be the median and what would be the IQR? Okay. So we're just going to change these to seconds, right? Fun. I'm pretty sure. Like, I feel like it's trickier than that. Okay. We're just multiplying these by 60 seconds. Cool. I think that's done it. And then here's the tricky one. In an effort to speed up customer service process, the company decides to streamline the series of push-button menus customers must navigate, cutting the time by 24 seconds. What will the median and IQR? Oh, okay, I see it. Okay. So they're only changing the what now, and I think that's the trick to this question, as long as I don't get tricked by it. If they make the calls faster, they're only changing the what of the distribution. So let's draw something out right here. What they're saying right now is they have a distribution, something like this. They just have a distribution where it has a mean of, I think, 312 seconds, we said. And the standard deviation, they didn't give us standard deviation, but they gave us like an IQR, which we wouldn't usually plot on here, but it's going to be less than that. The IQR is somewhere in here. I know it's z-score. That's about the IQR. Looks should be about it. So they gave us the IQR. And so what they're suggesting is, what they're going to suggest here is that to speed up their calls, they're going to do this. They're making it faster. They're making it faster. Now, what do you notice will change if I move the distribution like this? This is the visual of what they're suggesting. They're suggesting this right here. They're making it faster. So what will change about our distribution? It probably will help if I don't have the number, the center. Boom, right there. Nice job, Jake, Kirsten. Kirsten, we're throwing another 20 points. You're completely on track. They're going to change the center of the distribution, which median is a measure of center. So thank you, Kirsten. Perfect answer right there. They're changing the center. You could change the spread of the distribution but they didn't, but you would have to do this. So this would change the spread of the distribution. They're not doing that. They're just moving it over. So we should see the center of the distribution change by 24 seconds. So it'll be 288 if I can do the mental math, and the spread does not change. We got it. So this is a measure of spread right here. They're not changing the spread of the distribution. They're just changing the center. And so that's what's going to change. They're just shifting it over. They're making them faster. They're not changing the variation within the process. Kind of a good theoretical question. I like it. I like it. Oh, another theoretical question. A company selling clothing on the internet reports that the packages, it ships. I was like, if it ships has a median of 36 and an IQR of 24. Okay. The company plans to include a sales flyer that weighs 4 ounces in each package. What will the new median and IQR be? Okay. So same sort of deal right here. We were just covering this a moment ago. If you watched the previous question right before this, I know I put segments in these videos, but what they are saying is they have a distribution, and we'll assume it's normal. So the mean and median would be here. And then what they're going to do is, and they have variation of 4 around this, which is not a standard deviation. If a stat person watches this, here's your stat answer. There's the middle 50% at a z-score of 0.67, I think, 0.672. I've done way too many of these. I need to stop. Wow, magic color change pen. So that's the middle 50%. And what they're going to do is they're going to increase the weight of these, but not change the variation. So they're making these packages weigh more. So when you add the flyer to them, you're not changing the variation. You're just going to change the center of the distribution, but the variation would remain the same. If the company records the shipping weight of the packages with the sales flyers in pounds, and so we have to know that there's 16 pounds in an ounces. So now we would actually see a new median. Am I going to do this one correctly? I have flashbacks to every question I've ever gotten wrong. And I know I've had flashbacks on this one. So now we're going to go right here and 24 divided by 16. The reason I'm doing 16 is there's 16 ounces in a pound. And if Brian's done his math correctly, boom, we got it. So this is going to move the center and it's going to move the spread. So this is a shifting and scaling. Shifts the center and scales it down to a different value. This just increases the weight, but this is a total shift in the distribution for it. Hey, Brian, where can I find the Chapter 4 homework on the YouTube channel? You got it. We have that in a video, which I think is right here. Look at that. Thank you for asking, Jacob. Here's our 10-second answer. So there it is in the chat. That is for Chapter 4 homework, and I think it has most of the quiz. Actually, it has all the quiz. So you can go through here and watch me work the questions. How many more views does this have now? It's gotten 80 views in the last, hour. I wonder if it's due tonight. Maybe, I don't know. Possibly. Good question right there, Jacob. Glad to help you out right there. Good work, Jacob. You keep it up. Don't worry. You're welcome, Jacob. See, someone's like, I don't want to join. I don't want to ask the question. Don't worry. Don't worry. We got 3 more questions to go. We're going to finish all the quiz right here. All the quiz questions. Look at this. An incoming MBA student took a placement exam in economics and mathematics. In economics, she scored an 85 and an 88 in mathematics. There we go. The overall score on the economics had a mean of this, and standard deviation of this. The math had a mean of this, standard deviation of this. On which exam did she do better? We need to turn these both into whats. I just want to see one letter in the chat if someone can save me with this one letter. As I go and I take the question right here, I'm going to need one letter to say, Brian, turn these into some things. When I want to know which one is better, I think, Brian, turn this information into whats. What are we going to turn this info into to see which one's better? Let's do 2 colors here. So these are the observation for this. This is the observation for this. Sure, why not red? And this is the mean for this. Is that math? Thank you so much, Kirsten. Excellent work. I don't care. We're going crazy with these points, Kirsten. Thank you so much. You all right? We're going to turn them into z-scores to standardize them and see which is better. The economics. In economics, good. That is the economics. So here's the economics. I'm just in I'm going mad slowly. So Mubot's talking to the chat. And I really want to know why the pen changes colors randomly. I really want to know that. And there we go. So let's go ahead and do 88 minus 65. As long as I have my numbers lined up, we should be good. Let's do it in our head for fun. Is that 2.1111111? I think it is. Should be about, people can correct me if I'm wrong on that one. I'll check my math afterwards. Observation minus mean over standard deviation. Observation minus mean over standard deviation is going to be, so that is 1.8333. Okay, there we go. We should be good on these. Let's check the mathematics. Never hurts to check your math. Mental math is fun. At least I think it's fun. And here we go. And oh no. Oh, I was thinking of a ninth. I was wrong on this. I was thinking of a ninth. I didn't remember my long time ago I memorized what most like this one should be right. So I was thinking of a ninth when I did in my head. Ninths are easy because it's like 1/9 is 1, 3/9 is 3, which is a third, 4/9 is 4. Sixes are interesting because they're like, you have to do a half of a third, which is 0.1666, and then you, yeah, anyways, fun. I want you to hit like on this video. I need to start doing these things. I want you to hit like on this video if you like fractions, because I like fractions. Since she scored blank standard deviations above the mean, she scored above the mean in both. She did better on which one? Did we close it? Oh, no. It's down here at the very bottom. Which one did she do better on? This is the green. She has 1.833. I'm going to put it over here on the other screen so I can cheat and look at it. Okay. It'll make my life easier. Since she scored blank standard deviations above the mean in economics is red, so it's 2.09. And is it going to round up? How many standard deviations? 2 could. And she scored the mean economics and 1.833 standard deviations. It wants rounded. She did better on the economics. These are close. Oh my gosh. This is where I've done way too many of these. Did I misread it? Economics. Let me double check. Oh, wait. I have these reversed. Her economic score is an 85. And did I reverse these? Oh my gosh. And then that means she scored better in mathematics. I'm slowly, there we go. I even color-coded them. That's what I get. I think the pen color is in the style part of Word. There might be a style setting that is off. So yeah, Jacob, we need to figure that out because it drives me nuts that the pen does that. It even did it for the equal sign. Economics, I put in green, right? Yeah, and then I reversed it when I entered it. Yeah, so I reversed it. And then she scored better in mathematics. So I made that's the second error today, I think. Or is the third? I don't know. It's so easy to make errors on these. It's so easy. We've been working problems for a little over an hour now, so I totally get. Just tell me if you make small errors like that. Everyone knows I give points back. If you're like, hey, Brian, this decimal error, then just... Here's the thing. Maybe just retry it if it's like a big error, but we all make small errors. This is very similar to the ones we've been doing. We haven't done this one yet, so let's do it slowly. Fuel economy estimates for automobiles have a mean of this and a standard deviation of this. Assume that the model is normal. Thank you for telling me it's normal data, Mike Pearson. I appreciate that. Assume that the normal model, I think Alt Control. Oh, I should do that. We'll do that next. Remind me, Jacob. We'll do it right after this. Assume that a normal model can be used. Good deal. 24.8 is at the center of all of these. 7.2 is the standard deviation for only one. So confirming right here that this has a standard deviation of 7.2 confirms it's the answer. That is the answer. The 99.7 rule is shown right here visually, and it's going to be 3.2 to 46.4, just using the numbers. We're going to learn how to type in numbers. And there's the answer right there. About what percent of autos should get more than 32? So 32 has a z-score of what? 32, we're almost done here. We got one more problem to this, and we'll have done all of them. 32 has a z-score of what? 32 has a z-score of what? 32. They also don't let you control the pens as much. Word did an update a while ago, and I don't even know. I don't even know. So the total inside right now is 68, and that leaves outside total outside 32. And we're going to cut that in half for either side right here and do 16% here, 16% here. And we got it. 16% is going to be the amount of area above here. People are like, what happened to Brian? He's losing his mind. This is what happens when you do too much My Pearson. You slowly lose your mind. You delve, you go into madness. You look into the abyss, and the abyss looks back as you look into My Pearson. So this question is very similar. It wants between 32 and 39.2. Once again, cheat sheet is an amazing help, and you can tell that the answer is going to be 13.5. But let's not use the cheat sheet yet. Let's go back to our answer sheet on Word document number 42. So this one's a little bit trickier if you have to solve by hand, but we can still do it. We're going to put some additional information right here because we've worked most of this problem right here. We actually want to find out the area I'm about to shade, and the area shaded that we are interested in is this one. So let's first go and find out what these arrows are worth. So these arrows right here are going to be whatever 95 is left on the outside. So when we go and get the outside for 95, we're going to take 100 minus 95, divide that by 2, and that's what those arrows are worth. We have now figured out the arrows. So 2.5 and 2.5. But 2.5 is the area that is in total for what I'm about to shade. 2.5 is the total area. Oh no, I'm just lying right there. That's 16. 16 is the total area, and then 2.5 is from there over. So mathematically, what do we need to do here? So we want to only figure out that yellow shaded area, which is hard to see, but we don't want all 16%. And we're not interested in this right here, this 2.5, which is from here over. So what we're going to do mathematically is we are going to take and subtract off. We're just pretty much going to take this and take it out of there. We're going to go 16 minus 2.5. And that is how we get the answer. Nice job, Kirsten, right there. 13.5. Kirsten, how are you feeling about this chapter right now? Are you feeling much better about this chapter? Is it making more sense? This is all the practice we need. It's easy to make mistakes on this chapter, but the more you practice, you'll memorize these numbers. And I promise you, I can figure these out a lot quicker. And we're looking at the best. Is this the best? The worst, 2.5. So that's the lowest. That's at 95 down here, 10.4. And if you practice these problems, oh, Kirsten, that's so good to hear. If you practice these problems, just so people can see, we're going to do it. We're going to speed run this problem. Or let's speed run the last one. Maybe we've already done it. Okay. This is a speed run of the last problem. 2 seconds. Let's start up a stat 1 speed run. We haven't done it forever. This is to build confidence. Let's return and let's get a speed run going. Okay. Let me get the screen organized right here. We're going to speed run this problem to finish off office hours. Awesome office hours today, everybody. Lots of work done. And let's do this. You ready? Speed run of this last problem right here. Last problem, we've done one similar to it. And I'm going to like look in really close on it. Okay, here we go. 3, 2, 1. Can we do it under a minute? I bet we can. Hopefully no mistakes here. We have here the mean is 10.3 and the standard deviation is 4.9. This one right here, 10.3, 4.9. This is the answer. And then we have right here, it's so small, that we want the middle 68. That's going to be between 5.4 and 15.2. What percent of trees should have diameters below 0.5? So that's a z-score of that. That's going to be 2.5. What percent of trees should be between 20.1 and 25? 20.1 and 25. That's 34, 13.5, 2.35. 2.35. What percent of trees should be over 20.1 inches? So that's 2.5. And I think we've done it. There we go. 42 seconds, sub 42 right there. 42 seconds. And if my eyesight was a little bit better, I maybe could have done it faster. But when you get this down, like I've memorized the numbers. If people are wondering how I did this, please see this resource sheet right here. This sheet right here is a huge help. I know I can quote you any of these numbers, but just practicing, if you notice the other problems, we went through and we did all the problems by drawing it out. We did the last one there as a speed run for a little bit of fun, but here's the normal curve right here as a huge help. But with that, let's put on a little music right here and go back to space. It is practice makes perfect. The more you practice these problems, the more you know how to use the empirical rule, the easier these problems get. I understand this is a tough chapter and my background is just constantly breaking. We had 2 blips in the YouTube traffic today. But Kirsten, Jacob, everyone watching this, JG, so good to have you here. Excellent work. We're going to beat the tough chapters. We're going to win.
We're not going to let the boss win.
With that,
bye for now, everybody. Bye.